part 2. True, false, and fill in the blank. So you're either going to do true, false, or fill in the blank. 3 common states of matter are blank, blank, and blank. True or false, the particles of a liquid are attracted to one another but cannot move past each other. Blank is the study of matter. True or false? An increase in the temperature increases the molecular motion and increases the distance between atoms and molecules in solids, liquids, and gases. A blank in the speed of molecules allows the attractions between molecules to bring them a little closer together. True or false? Even when measuring the same temperature, the liquids in different thermometers can move to different heights depending on the liquid inside of them. The molecules of a liquid inside the thermometer increase in speed when the thermometer is blank. True or false? The atoms of a solid are very far apart and vibrate in fixed positions. Cooling a solid blanks the motion of atoms. True or false? Heating a gas completely stops all of its molecular motion. True or false? Air has mass. True or false? The molecules of a gas are not very attracted to each other. Short answer. You need to have at least one sentence for each of these questions. If the particles of a liquid are always moving, why don't they come apart from each other and become a gas? Question number 2. Water beads up on the surface of a freshly waxed car. If you use your finger to drag one drop very close to another and then let them touch, the 2 drops quickly join each other to become one bigger drop. What can you infer about water molecules based on this observation? Question number 3. Even though water in a clear glass appears still, a drop of food coloring placed at the surface will slowly move throughout the water. Eventually, without stirring or shaking, the water will become evenly colored. What can you infer about water molecules based on these observations? What do the circles and lines tell you about the arrangement, spacing, and speed of water molecules in room temperature water? Next question. In a little more than a tablespoon of water, there are about 60 billion trillion water molecules. If you could count 1 million water molecules every second, it would take about 2 million centuries to count all the water molecules in that tablespoon of water. What does this amazing fact tell you about the size of water molecules? What differences would you expect if at the same time you place yellow and blue food coloring in both hot and cold water? And then the last question, compare the speed of molecules in hot water compared to molecules in cold water. On the back, draw circles and motion lines in each box to show the differences in movement and arrangement of water molecules in cold, room temperature, and hot water. Thermometers have a very thin tube inside them that stretches up from a round bulb which holds most of the liquid. Why does the red liquid move up the tube when the thermometer is